Number 29 from section 9.5. So if we're going to do this, we're going to say first does it converge? So let's check
Double
the
factorial,
straight.
that's intense.
Let's check the straight alternating series.
Yes.
And so this alternating series is
Limit
easy.
as n approaches infinity of 1 over 1 plus root n definitely goes to 0. Therefore, the series negative 1 to the n over 1 plus root n converges by AST.
Wouldn't it be a term?
No, it diverges by n. Nth term only
No.
talks about divergence, and alternating series theorem talks about convergence.
Okay. So C is an alternating series. We say what happens to the nth term? It goes to 0. Our conclusion that it converges. Part 2. Does it converge absolutely? What happens if we take this and we put a big old absolute value over and around it?
Okay, well you can eliminate if we can clean it up. So as the value of 1 plus 1 over root n.
Okay. And now what we say is, what does that look like?
That looks like 1 over root n,
1 over root n.
which we know is divergent. We just have to prove it. So compared to 1 over root n,
Right, compare to the series 1 over root n, which is a known divergent series because it's a p series.
with p equal 1/2, p less than 1.
P series p less than 1. We're okay with that step, right? We are able to distill this down to 1 over root n, and we know that that's divergent. So now let's go ahead and apply the limit comparison test. The limit as n approaches infinity of
1 over, yeah. Alright,
this
so you can't
this
cancel.
nth term multiplied by the reciprocal of the other nth term.
You just get root n over root n when it all goes. It comes down to root n over root
It gets root n over 1 plus root n, which you can either do intuitively, or you can divide everything by root n and you get 1 over 1 plus, sorry, 1 over root n plus 1. Regardless,
close to
it's
infinity.
going to 1,
Yeah.
which is,
Finite and positive. Therefore, the series converges by limit comparison.
yeah, therefore, the
test.
original, which is the absolute value, one to infinity diverges, because if this diverges, that also diverges.
Oh, we were comparing it to a divergent series.
We're comparing it to a convergent series, so it diverges by limit comparison test. This thing and that thing always have to match if we did the job right. So it converges, but not absolutely. So what do we call a series that converges but not absolutely? Conditionally convergent. Is that good?
Yep.
Are we getting this, Eric?
I think so.
Can we do one with the endpoint thing where you were supposed to find it at the endpoints?
I'm just working through the list. I'm going hard as I can. I really am.
We go with endpoints.
Where you touch the endpoints to find